Hello everyone, in today's lecture we will discuss a problem that is related to finding Christoffel symbols. Question is, find the Christoffel symbols of the metric tensor in plane polar coordinates, and the metric tensor is given by GAB, that is equal to 1 0 0 r square, and the inverse of this metric tensor is given by this one. Here you know that this metric tensor is in a diagonal form. Okay, so we just have to take the reciprocal of the main diagonal entries and it will give us an inverse. Now students, we know that the formula for finding Christoffel symbols is given by this one, and here D represents a dummy index. Now if we substitute the values, first of all we will take the value A is equal to 1, B and C is equal to 1. Then we will get this one. This is another representation of Christoffel symbols. You can either represent them by this one, like gamma 1 1 1, or by this. Okay, now we know that here we are dealing in a plane polar coordinates. Okay, means we have a plane, so the variation of D will be that equal to the dimension of a manifold, and D is a dummy index, so we will write it in a sum over form. Okay, first of all we will put the value of D is equal to 1 in this whole term, and then value 2. Now students, we know that here G11 is equal to 1 and G12 is equal to 0. So G12 is equal to 0, so this whole term vanishes, and here G11 comma 1 actually represents the partial derivative of G11 with respect to 1, and G11 is equal to 1, so its partial derivative with respect to R is equal to 0. So 1 1 1, that is equal to 0. In a similar manner, 1 1 2, that is equal to this one, and G12 is equal to 0 because non-diagonal entry is equal to 0. And here if we take the partial derivative of G11 with respect to theta, then definitely it is equal to 1 because G11 is a constant value, so its partial derivative will vanish. Okay, and due to symmetry, 1 2 1 will also become equal to 0. In a similar manner, we can find out the other values like 2 1 1, that is equal to 0, 2 2 2, that is equal to 0. But now over here we have G21, so the first term will vanish because it is a non-diagonal entry. Okay, and G22, that is equal to 1 by r square, and here G22 means the partial derivative of G22 with respect to 1 means the partial derivative of G22 with respect to r. Now students, you know that G22 is actually r square, so partial derivative with respect to r will give us 2r. So here we will get this value 1 by r, and due to symmetry 2 2 1 will become equal to 1 by r. In a similar manner, 1 2 2 will give us a value minus r. So non-vanishing Christoffel symbols, or you can say the non-zero Christoffel symbols, are given by this one, and these are the Christoffel symbols for a plane polar coordinates. This is all about this lecture. Thank you so much.